section, which is 6.3, but we're still talking about volumes. These are volumes by something called cylindrical shells. So we're going to learn a new method for finding volumes. But before I talk about this new method, I want to give you some kind of motivation as to why you would even want to have another way to find volume. So let's look at a problem similar to ones we've looked at the past two meetings. So let's consider the problem of finding the volume of the solid obtained by rotating about the y-axis, the region bounded by y equals 2x squared minus x cubed and y equals 0. So what did we do first when we did these volume problems? We need a picture of our region, right, in general. So I see these functions here, y equals 2x squared minus x cubed and y equals 0. We find their intersection points, just setting them equal to each other. Okay, so I'll set 0 equal 2x squared minus x cubed. I've already got 0 on one side, so I can jump to factoring. What can I factor out here? X squared. Yep, you want to factor out as much as you can. In this case, x squared. 2 minus x. So I'm getting two solutions. I'll get x equals 0 and x equals 2. You plug them into either function to get your intersection points. So if I go with the second function, y equals 0, you're going to get the points 0, 0, and 2, 0. All right, so I'm ready to draw my picture. I'll do it on the right-hand side here. They intersect at 0, 0. And 2, 0. Y equals 0, that's just my x-axis. So plug in, I need one more point for this other function here. So if I plug in 1 into it, I think you get 1. This is a cubic function. It's going to look like this. Okay. All right, I want to rotate about the y-axis. Oops, I didn't mean to do that. Rotate about the y-axis. So we're doing this just like we did before. How should I take my strip? Should they be vertical or horizontal? They want horizontal. You want them to be perpendicular to your rotation line. So when I take my strips here, they should be horizontal. And I'm going to rotate that around my y-axis. Do I get a disc or do I get a washer? A washer. There's a gap between my strip and my rotation line, so I'm going to get a washer. Okay, so we're still talking about the same method we've been talking about. We said we get a washer. And remember this formula, it's pi big R squared minus pi little r squared. I'm rotating about the y-axis. So if you look at your strip, there's a left and a right, which means I should integrate in terms of which variable, x or y? Y. We want to integrate in terms of y. So we're going to need to integrate in terms of y. Now, left and right, these two radiuses, my little one and my big one, both come from the same function. They both come from this function y equals 2x squared minus x cubed. I need to solve for x in this equation. Is that easy to do? Solve for x? Could you solve for x here? Can't really, right? There's not a single x, and we have these powers here, x squared and x cubed. So the problem is we need to solve for x in this equation here, but that is difficult. For us to do. So I know in all of the examples we worked previously that our method for finding volume worked out, but for this one, I can't really keep going. I'm stuck here because I need to solve for x. It's really hard to do. So our solution is that we're going to use a new method, and I put it in the title, called the method of cylindrical shells.